When you're building something, you want to make sure it works. And you make sure that something works by testing it, right? It's the same with JavaScript code. You need to make sure that your JavaScript code works before you launch it. In this video, I'll show you how web developers test their JavaScript code. By the end of this video, you'll be able to identify the various reasons why a developer would want to test their code, explain how the red-green refactor cycle relates to testing, differentiate between manual and automated testing, and demonstrate an understanding of unit testing. So how do web developers test their code? Let's find out by coding a custom concat strings function. For example, I can create a concat strings function to join any two strings that I give it. In this case, I want the function to join string A and string B that are received as arguments and return the result. For example, I could write concat strings ABC and then DEF, and the returned result would be ABCDEF. When the function receives number 1 and 2, it returns a 3 as a number instead of a string of 1 and 2 together, i.e. 1, 2. I can also signal what I want my function to do by adding comments to it. Adding comments will help my team understand and remember the expected behavior that I had for the function. A more detailed description would be a good way to make it more obvious as to what my intention is for each argument. In the comments, I can even specify the expected behavior when specific values are given to the function. Adding comments is a step in the right direction, but it has downsides. It allows me to write anything I like, so there are no limits on ambiguity. Also, the comment doesn't need to follow any set structure. There are many custom testing frameworks available in JavaScript. One of the strengths of such frameworks is that I don't have to use comments to describe my expectations. The test syntax itself becomes expectation documenting. When I write tests, those tests are a better alternative to comments in my source code, because they specify what expectations my source code is trying to satisfy. Tests are also callable, meaning I can execute tests to check if expectations are met. As I demonstrated earlier, I could execute the concat strings function, with the first argument being the string ABC, and the second argument the string DEF. I would then expect the function to return ABCDEF when I call it. To write this as an expectation, in some testing frameworks, such as Jest, I can use the function that has the name expect. I then pass the call to the concat strings function with the specific arguments. Then I add the toBe function, which is another testing function, and I pass it the value of what I'm expecting this code to produce. So, I'm essentially stating that I expect the calling concat strings with ABC and DEF will return the value ABCDEF. Testing in JavaScript lets me verify that the function is behaving in the way I intended. Testing code in this way ensures three things: conciseness, as it's straightforward and to the point, since there are only two function calls to explain what is the expected result; clarity, because you know exactly what argument you're providing; and repeatability, as you can run it again and again with the same arguments each time. Now, I could run multiple function calls using this syntax. For example, I could have expected concat strings with the strings 1, 2, 3 and 4, 5, 6 as arguments, and then the function to be with the argument 1, 2, 3, 4, 5, 6. And in each instance, the expectations will be correct, and the code will behave as expected. In testing terminology, you would say that your tests are passing. But I'm only halfway there, because it's still possible for my code to fail an expectation. For example, if I run the expect method and pass it an invocation of the concat strings function with numbers 1 and 2 as arguments, my expectation of 12 being the result will fail. This is because when I use the plus operator with two values of the number type, it performs the mathematical operation of addition instead of joining the two numbers together to form the number 12, like it would form ABCDEF if I gave it the arguments of ABC and DEF. When tests fail, you say that they are red, and when they pass, you say that they are green. If a test fails, then it's a sign that I need to write the code in such a way that its test passes. Once my test passes, I might improve the app's code without changing its behavior and without changing the test code. Changing code structure without changing its functionality, this is known as refactoring. Refactoring is the process in which I write my feature code so that it runs more efficiently or that it's easier to read and thus easier to understand for other programmers on the team. This is done without affecting the results that the code produces. The only obvious change should be perhaps the test itself, taking less time to run because I've optimized my source code. You won't always write your code in a way that meets all expectations, so it's most likely that some of your tests will be red and some of them will be green. Red tests are a guide as to how you need to improve your code to cater for unmet expectations. So, as you continue to refine your code in response to red tests, it becomes a sort of cyclical activity. This is often described as the red-green refactor cycle. This cycle is the basis of the test-driven development, or TDD, approach to programming. Let me explain the TDD approach. First, you write a failing test. Then, you write your source code so that the previously failing test now passes. Finally, you optimize your source code without changing its results. There are many advantages of having code that tests other code. For example, you can run it as many times as you want. You can run the testing code automatically, and the tests can be repeated without significant cost in time or effort. To sum up, testing is how you verify the expectations you have regarding the behavior of your code.